ask Melano's questions later, though. Thank you.
Yeah, no, totally understandable if you want to get up and hear Jim's comments. Hi, I'm Tony Colaprete, and I'm going to talk to you today about some preliminary work we've been doing with metallic lines, and we're finally getting to the point where it's starting to write this up and hopefully get it out for publication. It's made with UVS instruments. Yeah, I'm totally moving fast. And it was done for UVS noon activities. There's lots of other activities. We're focusing on these for principal reasons is there's often our best viewing geometry, peak concentrations predicted for species. And while there's ever the presence of scatter, the good news is in the ultraviolet, all of our optics rejected light really well, and that's really important when you're staring 20 kilometers above the lunar lit surface at noon. You saw this in Menelaos' talk, as sodium and potassium. We're basically following very similar analysis techniques. So if you're interested in how we're going about finding these species and looking for the lines, you can go and look up that in the literature, in the supplemental material. Again, as I want to just emphasize, we're really using right now the ultraviolet lines to search for species and at least place good upper limits on them. And I just want to give an example of the kind of spectra we get here. This shows the solar spectrum. It's a model solar spectrum, EFA 490. And then a UVS limb observation and nadir divided by solar. So that basically the I over F, which is the blue. And there's a factor of about 20,000 between the two. So we see, this is solar scatter we see in the limb. It's beat down at about a factor of 20,000 times from the nadir observations, basically, when we're looking straight down at the surface. And what you can see, though, is there's a lot of structure down here that isn't solar, and that's actually where we see and look for lines. This is general reflectance units, and I've got scaled radiances. The radiance levels we're talking about are in the handfuls of Rayleigh. So 1, 2 to 10 Rayleigh kind of brightnesses, so very dim. This shows a couple of titanium lines, and as we're finding, titanium is often problematic in that there are many lines, and they seem to interfere often with other lines we want to look at. But this shows, again, oops, wrong button. This shows, again, the nadir and solar viewing. And nadir is nice in that we can look down, see the limb, or see the lunar surface. We can model the solar spectrum very nicely that way with the lunar reflectance. And we can actually use it as a scattering model, subtract out scattering. And that's often how we can derive a lot of these line strengths. But often just in the limb, you can just see certain peaks that come up, and it's nice because you can compare that to the solar spectrum and say, that doesn't look like anything scattering in the solar spectrum. Is there anything that could explain it? And sure enough, there's a titanium double peak right about there. Other times, you do see lots of solar absorption bands and whatnot, and they interfere with where you might hope to see a spectral line. So it takes a lot of work, and you have to be careful. This just shows a fit using a spectral model that involves what we would think we would see with the instrument response function, and that shows we can actually fit these things pretty well now knowing how the instrument really responds. So this is titanium. This is an example of a fun, complicated line that we're looking at right now. It's both a ground state of aluminum and a titanium line combination. And here's a similar figure what I showed before. Actually, when you scale some of our nadir and limb observations, we saw an excess in some of our dim nadir observations, and we looked at, well, that's interesting. Is it real? We went back and looked at it and started modeling it, and it models very nicely here if you combined aluminum and titanium lines that you would expect to see right at those wavelengths. So, this is all structure around it that you have to be careful about. Some of it's solar, some of it's instrument, some of it's other. And so that's the fun we have in digging through all this rich spectra. And it is a task, it's an art as well. The other thing that makes that we always go to and look at to make sure we're looking at something real and not artificial is a lot of times we have enough signal and noise on these lines, as you can tell from this previous, there's certainly signal there. Plotted as a function of time, and if it behaves like something other than just noise or the sun or constant or whatever, it again tells you a little bit about what it is you're looking at. This shows aluminum, titanium, magnesium as a function of date plotted. This is just line strength. It has to be corrected for velocity, effects on the G factor, et cetera, before you get total column amounts, and we're doing that. But it shows there is at least some periodicity to it, especially the titanium, which we can find fairly strong lines. We have nice periodicity that looks very similar to, like, for example, the potassium. The aluminum and magnesium are weaker lines, or we have more noise about them. As I mentioned, I think often our aluminum lines are interfered with by titanium. And you can kind of see maybe titanium poking up in here. And, you know, for that last plot, we have to go back there and kind of detangle some of these. But this is really what we're after, is one, observing them, detecting them, but also then trying to get some information out of them in terms of their source and sinks, like Menelaus has described. The red lines indicate full moon positions, just for reference. The other thing we've looked at again is these line strengths as a function of scintigraphic longitude. Again, that will tell us if there's if this is a real observation or what information exists in there. This shows, again, titanium as a function of longitude. I've overplotted then the field of view cut across the surface is this black, kind of an instantaneous what the titanium surface concentration would be, and then I kind of smoothed it out because we, of course, have a 1 degree field of view and are looking at about a 400 kilometer throw across the surface, integrating across that column. And you can see there's a pretty good match between it, although there are differences that are important. Another thing we can do then is look at out-of-band measurements, and at the continuum basically is how we get at this line strength. And this shows basically the normalized, sorry about that. I'm going the wrong way. Of course. The normalized line strength, which is the blue curve here, showing again plot against longitude, and then the continuum line strength. They're normalized with respect to each other, basically demonstrating that at least the background we're subtracting off doesn't also change with longitude, at least at the same magnitude. We do definitely see scatter changes, so we want to be careful we're not just measuring scatter. This shows then also magnesium and aluminum. And again, magnesium has a very similar profile as the titanium. I've also overplotted the blue line as a surface concentration of magnesium. And then aluminum, and aluminum's nice, and I'm noticing there's some strange things going on with fonts. Aluminum's nice in that it doesn't look like the other two. And so if everything looked the same, I'd be a little suspicious, but it doesn't. It actually is out of phase by about 180 degrees with aluminum or with titanium and magnesium. And that's interesting because, indeed, aluminum is out of phase with those. It has its lowest concentrations where you see the highest concentrations of magnesium and aluminum, and it actually fits quite nicely to the surface concentrations. So that's where we're starting out now. Menelaus mentioned looking at some of these metallic lines, and these are a couple early models that he's produced where we are trying to understand the contributions of the various sources and sinks. And we've got, immediately made some, at least some initial progress in being able to reproduce general shapes and magnitudes for these types of observations. Again, we really need to go from line strength to concentrations here to really do the final work, but I think we're on the right track in terms of being able to pull out sufficient data to really constrain the modeling efforts. And I'll leave with one last slide that I'd like to show just to be controversial. This came up out of a LADEE science team meeting a couple years back now, I guess, and some NMS folks and myself were talking, Eddie and I were talking, and he was showing this argon variation as a function of, I keep hitting the wrong button, sorry about that, as a function of date, and that's the blue triangles with error bars. And I said, wow, that looks a lot like some of my sodium concentrations as a function of date, and so we shared data and overplotted and got this plot. And so the sodium, the highs and lows, because sodium's got this variation, monthly variation, I plotted both those averages. and they're lined up. And then I went ahead and did titanium too. Titanium's right on top of it as well. So an interesting trend, you know, like Matt said in his presentation, it could just totally be coincidence or not. I've had a few people come up and give me some interesting ideas why these might actually fit, including we aren't seeing what we're saying we're seeing. So which is always a chance of that, right? So with that, told you I'd be fast. We're making a lot of progress using the ultraviolet, UVS ultraviolet data. There's a lot of, as anyone who's worked with spectroscopy knows, a lot of work that needs to go into just understanding the instrument, pulling out all the little artifacts and idiosyncrasies and that sort. But we're getting to the point now where we're going to write this up, specifically talking about the titanium and magnesium and aluminum, but they aren't the only things we're also looking at. We're looking at, for example, oxygen, calcium, and things like that as well. And with that, thank you.
All right, thank you. And Brad just asked me to skip questions and have everyone go over and see Jim Green talk.